I'm Andrey. I'm working as software engineer at JetBrains, mostly working on C# features for ReSharper and Rider. Lately, I've been working on nullable reference types and source generators support in ReSharper. And I've been very interested in metaprogramming for quite some years now. And because of that, when source generators became available, I was very curious where do they fit among existing tools, what are their pros and cons, and when I should use them. So in this session, I'll briefly introduce source generators to you. There will be 2 live demo sessions. In the first one, I'll focus on quickly building a simple yet useful source generator from scratch. And after that, I'll compare source generators with other metaprogramming tools we have available today. And in the second demo, I'll focus on some advanced scenarios and best practices when using source generators. But first, let's discuss why we need source generators and what problems are going to be solved by them. And first and foremost, it's generating boilerplate code. So if you have some standard implementation of equality members or toString methods in lots of types in your solution, instead of coding them yourself, you can simply delegate this work to a source generator, and in this case, you won't even have to update them every time you add or remove some members to the containing type. Of course, they can also be used to do type generation from schemas, to do some object mapping code, to produce code for object materialization from some service. And because we can generate boilerplate code easily now, we can also have some performance optimizations. For example, we can get rid of reflection in serialization, can register types for dependency injection without reflection. I'll get back to it a bit later. And first, let's start with a simple example that is likely familiar to most people. It's an interface called INotifyPropertyChanged. It has a single event notifying its listeners that some property of an object has changed and perhaps it needs to be updated on the user interface or some other logic should take place. And because it's just a single event, it's really easy to implement in any type, for example, a car model with a speed property. But now we have a problem because this auto property doesn't fire any notifications about its changes. So instead, I'll have to write it as a regular property with the backing fields, and in its setter, I'll fire the notification. And that's already a lot of code. And what's even worse, every time I'll need to change something, for example, the name of this property and its type, I'll have to update almost every single line in this code. And it's a lot of places. What we can do here, we can only leave backing fields in our model and generate notification properties with a source generator, because they all follow exactly the same pattern. And I'll show you how it looks like with and without source generators. So you might notice that there is a lot less code with source generators. And this code won't grow very fast when you add new properties, for example, a model name for this car or its number of doors. So when at some point you'll add some business logic, for example, an acceleration method that will increase the speed of this car by 10%, you'll still be able to see what this type is about, what members are available there, and you won't have to scroll multiple screens of boilerplate. So what are source generators? As I mentioned before, it's a new metaprogramming tool from Microsoft. Basically, you are going to write a type that will be a part of the compilation process. It can access a model of your code and generate new files based on it. So Rosen begins the compilation of your project. It reaches some source generation step of compilation. It transfers control to your type along with everything it knows about the target project. And based on this information, you can generate new source code that will be added as an input to compilation, and it will resume as if these files were there forever. So let's get to the first demo. And I have a website called SourceGenDev, where you can upload a bunch of examples provided by Microsoft. And one of them is actually implementing the INotifyPropertyChanged interface. And here we have the actual source code for our program. There is an example view model type with a bunch of backing fields and an auto-notify attribute. There is a program that simply subscribes to the property changed event and changes a couple of properties to verify that everything works and we are getting the notifications. And we can check what was added to this program by a source generator. It's the auto-notify attribute and a partial declaration of our example view model type. So it's essentially a part of this type that implements the INotifyPropertyChanged interface and adds the property changed event and the properties that fire the notifications. And on the top right, you can see the actual source code for this generator. But it might seem that there is a lot of code, and in order to work with this, you have to be familiar with Roslyn API, how the compiler builds its syntax trees, what types are available, because if you check it for the first time, you'll see a lot of types you probably don't know, such as isyntax receiver, attribute data typed constant. You'll see some safecasts to C# compilation, C# parse options, add syntax trees, C# syntax tree parse text, source text from. And what to do if you don't know all these types? It might seem that you have to be familiar with Roslyn API to start working with them. And in my first demo, I want to show you that everything you need to know is about 3 methods total, and everything else will be easy to find with code completion and derived type search. So here I have a car model type with 3 backend fields. I've demonstrated on one of the previous slides an acceleration method, and a lot of boilerplate implementing the property changed notifications for these backend fields. And this program simply subscribes to its property changed event and fires a couple of notifications to verify that I'm getting notifications for model name changes, for number of doors property changed, for speed property changed. And let's remove all this boilerplate with the help from source generators. I'll need a new project where I'll declare my generator. It has to be a new .NET Standard 2.0 library. Because this assembly will be loaded in the Visual Studio process. You cannot use anything fancy such as .NET Core 5, and it has to be .NET Standard 2.0, don't forget that. And I'll need a couple of packages in order to work with the compiler API. I won't focus on this now, but you'll be able to find source code for this demo on my GitHub. And you'll also be able to check these packages in any example focusing on source generators. For a source generator, I need to declare a type that will implement iSourceGenerator interface, and it has to be annotated with a generator attribute. The interface itself contains just 2 methods, initialize. They won't need it there yet. I'll get back to it in the second demo. And execute where the magic happens. And here you have access to context compilation, which is basically everything the compiler knows about the target project. For example, you can access any types that are available in the target project with get type by metadata name. For example, here I'm interested in system component model INotifyPropertyChanged interface, since I'm going to implement it in a couple of types. So let's notify interface. And you have access to compilation syntax trees. Essentially, one syntax tree is one file in the target project. So for each file, as with any tree, you can access its root. And you can check descendant nodes and self. And since I'm going to work with type declarations, I'm only interested in class declaration syntax elements. And here you might want to stop me and ask, okay, how we should know that this type even exists if we are not familiar with how Roslyn works? And there are 2 methods you can use. First, you can check what descendant nodes and self return to you. And it's a collection of syntax node element. You can check derived types from it. And these are every syntax element available in C# language. Usually they have quite descriptive names, so you won't have any problems if you search, for example, for record. And there is a record declaration syntax if you want to extend records only. If you want to do something with interfaces, there is an interface declaration syntax. With class, there is a bunch of types. The first one is class declaration syntax, which is exactly what we need. But what if you don't know how to name some method? For example, a method call. How would you name this element? If you cannot guess the name of the syntax element you need, you have another website that can help you. It's called SharpLab. You can switch it to syntax tree mode and type any code there you are interested in, for example, console write line. And you'll be able to see that console write line is an invocation expression with a simple member access expression qualifier and an empty argument list. So if you are not sure what syntax elements are produced by the compiler, you can simply put your code on SharpLab and check the generated syntax tree. So let's get back to our example. And syntax elements is essentially what is written in the code editor. So there is a class keyword, there is some name identifier. And what we need is semantics. What members are available in this type, what interfaces does it implement, what attributes are there. And to move from syntax to semantics, you can use compilation, get semantic model from this syntax tree. It's a variable for that. And you can move to semantics with semantic model, get declared symbol, this syntax declaration. And these are the three methods you really need to know. Semantic model, get declared symbol, compilation, get semantic model, and compilation, get type by metadata name. So everything else you'll be able to find with code completion. For example, since I'm working with types here, I'm interested in type symbols. And I'm interested only in types that already implement my INotifyPropertyChanged interface. So there is an interfaces property, and I can check that one of them is my INotifyPropertyChanged interface. I can put them in a hash set, and this will be the types I'm going to extend. So let's name them target types. And for each such a type, I'm going to provide declarations that will implement this interface. So target types for each. I'm going to provide source code, generate property changed for this target type. You don't have to provide any compiler structures. You need to provide a simple string as with code in the editor. So here I'm going to use string interpolation. I'll declare it using system component model here to use the INotifyPropertyChanged interface. And the namespace that will be the same as containing namespace of my partial type I'm going to extend. There will be a partial class with the same name as the type I'm extending. So it's essentially a part of the same type. And since I'm going to implement the INotifyPropertyChanged interface, I can also move the property-changed event itself in the generated part. So let's simply copy it. It's easy to do because we're working with simple strings. And I'll need to provide properties that will fire these notifications. So generate properties for this target type. And here I don't know yet how many properties there will be. So I'll need a string builder. And I'll need to check what members are available in the target type. Code completion is your friend here. You can type members, and there is a getMembers method. I'm interested in fields only, so I can type field, and there is an iField symbol, which is exactly what I need. And I won't rely on any fancy attribute-based configuration here. So instead, I'll rely on simple naming convention. If something is, name it with a field suffix, I'm going to provide a property that will fire notification when I'll update its value. So let's check that the name of this backend field ends with my backend field suffix. And for each such a field, I'm going to generate a property with a name that will be the same as the backend field name, except for the suffix length. So without the backend field suffix. That's our C#8 feature. And now I have to provide the actual property implementation. Apparently my Visual Studio is lagging, don't worry. And builder append line. And again, I can use one of the properties I declare in my actual program to use it as a template for what I'm going to provide. Simply paste it here, escape the curly braces, and update it because it's not always a string property. I need to use field symbol type as a return type for this property. I need the name I've just calculated. I'll return backend field from its getter. I'll update my field symbol, the setter, and I'll fire the notification for the property name. So I have to return the string builder. And now I have left is to add this source code to my actual target project, this context add source. I'll need to provide a name for this file, for example, the same as the target type name with notify cs suffix, and provide the source code. Now let's add this generator to our main program. And I'll also have to tell the compilers that it's not a regular reference. I'm not going to use types provided by it. And it's actually an analyzer, so it will do something with my code. So its output item type is analyzer. And if I did everything correct and didn't make any typos, I can now simply remove all this boilerplate from my type, mark it as partial, and run this program again. Everything should work. Let's check it. Yeah, everything works, everything compiles. I'm still getting notifications whenever I change any properties, for example, the model name, the number of doors, the speed property. And the only problem you might have noticed is that my code editor looks a bit broken. There is a lot of red code. And that happens because Roslyn, which is the underlying engine that powers Visual Studio, will only update generator references once you open a solution. And when I opened this solution, there was no source generator, so I have to close it and open it again. If you are not using ResHarper, you'll have to fully restart your IDE here. Don't worry, you don't have to do this every time you change something in your code editor and need to restart the generator. This is only required if you change the generator itself. And if this is a problem for you, for example, if you want to develop some code and get immediate feedback on every time you change something in a generator, you can switch to JetBrains Rider, which supports hot reload for source generators. And now everything works. So let me show you that you don't have to restart your IDE every time you change something. So you can add a new double property, weight of this car, weight field. And as soon as you add this property, you can see it in code completion. You will be able to get notifications for it. It will simply work as soon as you've added the backend field. And now you might have a couple of questions about the generated code, because right now there is some code in the car model type that we don't see, and how we can check it and check that everything works properly, how we can debug it if there is some problem. And these errors are usually quite hard for metaprogramming tools because you not always have the source code available. And since Visual Studio 16.9, you can simply find the reference to this generator in your Solution Explorer, and there will be a list of files generated from this generator. But in large projects, it might not be convenient because there will be a lot of files that will not be grouped. So instead, I suggest you to work with this generated code as if it was your own code. So I can navigate to a car model type, and I'll see that there are two parts of it, one in my main program and one in the generator folder. I can navigate to this type. There will be the 4 properties I've declared. I will be able to check the source code for them. And I'll be able to set a breakpoint here and simply debug this code without any problems the next time I'll run this application. Let's check it. And yep, I can check what value I've assigned to the backend field, and I can debug this code as my own. And another interesting question is, okay, how can we test the generation process itself? And for this, you can ask the compiler to compile some arbitrary source and run some generators over it. I have a project prepared for this in advance. You can check exactly how it works on my GitHub after the talk. There will be a link. So I simply provide some source code. I'll create compilation from it. The code is a bit cumbersome, so let's not focus on it. Check on my GitHub if you want to test your source generators. And then I can run my generator over this code and check that the returned compilation has some syntax trees that include my notify.cs file. And I can check its source code. I will be able to check that my index backend field has resulted in a new property that fires the notifications, and the regular field that doesn't follow my naming convention wasn't processed at all. And of course, in this case, you'll be able to set a breakpoint in the generator and hit it when you run this test. But what if something is wrong in production, but not in our test code? And because our tests are fine, we don't know what the problem is. How can we debug it? And for this, you can add a line debugger launch to your generator. And the next time you'll compile your project, it will be prompted to attach a debugger. For example, you can choose the same Visual Studio instance and let it debug its own build process. So let's try it and see how it's different from our test run. For example, you'll be able to see that in a real project, there is not one file, but 3, and only one of them is my program CS, and 2 others are auto-generated files with some assembly-wide attributes. Don't forget to remove this line after you finish debugging the problem, because as I mentioned before, Roslyn will only update generator references once you open a solution. So if this line is in the compiled assembly, the moment you open your solution, you'll be prompted to attach a debugger every time you change something in your code editor, which is quite a lot. So don't forget to remove this line and fix the behavior in test. And before we'll go to the next section, I want to mention a couple of things I've overlooked for the sake of simplicity in this generator, and you might want to handle them in the actual generator. For example, here I've only used class declaration syntax. There is a new C#9 feature called records. You might want to support them as well. For this, you'll also have to update this keyword to record. You might want to check that containing namespace is not the global namespace for the assembly, in which case it will be empty and this code won't compile. You might want to check that this class is nested in some other type, in which case you'll have to declare a containing declaration as well. And you might also want to check whether the interface is implemented directly or is inherited from some base type. That's the difference between interfaces and all interfaces. The same with breaking fields. You might want to check whether they're declared in your own type or they're inherited from some base type. These checks are relatively straightforward, so I don't want to waste time for this because I believe that you won't have any problems doing them. So let's get back to our demo. And I hope that I've demonstrated that in just about 15 minutes, you can declare a generator that will save thousands of lines of boilerplate in an actual source code. For example, in real-world projects, there might be projects with dozens of types implementing INotifyPropertyChanged for dozens of properties. And now you might notice that implementing this interface isn't actually all that new. And before, I used Fody to implement exactly the same interface without all this boilerplate. So should we use source generators because they are new, shiny, and provided by Microsoft? Or do they have some unique advantages over existing tools, for example, text templates, IL weaving, IL generator? And I'm going to compare them to IL weaving, which is probably the most common way to extending some functionality. So the main difference here is that source generators can only add new files, and IL weaving rewrites bytecode after the assembly is compiled. If you haven't worked with Fody, it looks like this. You simply implement the interface in some type, declare the PropertyChanged property event, and declare some auto properties. And after this code is compiled, these properties are transformed to regular properties with backing fields that will fire some notifications from the setters. So it works like magic, and I want to highlight a few key differences with source generators here. For example, in order to alter some bytecode, you first need to compile it, and for that, you have to declare the PropertyChanged event, because without it, the project won't compile, you don't have any bytecode. So with IL weaving, it might be hard to declare something that is required for compilation. For example, some members that you need to implement from interfaces. But on the other hand, with source generators, you won't be able to declare regular auto properties there, because the only option available for source generators is to add some new sources to your solution. So if you already have an auto property, it already doesn't fire any notifications. Source generators cannot change that. Instead, you'll have to rely on backing fields and either some naming conventions or attribute configurations to tell the generator how to generate a property from this backing field. And one other interesting difference is that whatever you add from a source generator will be visible at compile time. Usually it's quite beneficial because you don't care whether you've declared a member yourself or whether it was generated, you can simply use it. But for property changed, it might be a bit cumbersome because you'll have the breaking fields in code completion, you can accidentally assign some new value to it instead of the property and miss the notification. So back to pros and cons of generators over IL weaving. Actually, source generators are superior in many aspects. For example, compiler will check the string you provide to it instead of writing some bytecode that might result in invalid program exception if you do it wrong. You have no problems navigating to the generated sources and debugging it, something that might be very hard with IL weaving because you don't have the actual source code. And the only disadvantages of source generators are they require partial to extend any type, which is probably not a big deal. And second, they cannot change existing code, whereas IL weaving can remove or change anything, for example, to optimize your code. And this brings us to the question whether IL weaving is obsolete now or not. But as I mentioned before, IL weaving can alter existing methods, and this is often used to add some functional aspects to your code. For example, to swallow exceptions, to do some login injection, to drop trace messages. For example, with Fody, you can drop a line in a log every time you create a disposable object and every time it reaches finalization queue. So with these logs, you'll be able to find where you've created an object that you forgot to dispose. And according to the official documentation of source generators, all these tasks are code rewriting tasks. They include optimization, IL weaving, call site rewriting, and login injection. And while they have many valuable use cases, they do not fit into the idea of source generation. And this is a bit disappointing. So let me show you that actually you are still able to provide some extension points for source generators, for example, for login injection. And by this, we usually understand that we want to log something at the beginning of a method, for example, the values of the call arguments, and at the end of a method, log its execution type, whether there were any returned values, whether there were any exceptions. For example, with PostSharp, it looks like this. You simply add a log attribute to some method, and after the compilation, there are about 75 lines of code. It's a big enterprise framework that boil down to the following. First, let's log the parameter values at the beginning of a method, then under a try statement, execute the actual source code that was there before the transformation. And after that, either log that the method has ended successfully or that there was some exceptions. So can we do this with source generators? For example, here there is some service that might be part of some bank service, for example, to get clients' accounts and get their balance. And in object-oriented programming, if you want some extension point, you simply add another layer of abstraction. So let's introduce an interface for this service. And now I can generate a decorator for this interface from a generator. For example, I can implement the same interface in a proxy implementation. I'll accept the actual underlying business logic in my constructor, and then implement every single method with the decorators that will add all the required logging, and then simply delegate the control to the underlying object. With this technique, I'll be able to add whatever I need before and after the call, and I'll only have problems changing something deep within a method, which is probably not needed very often. And I'll also have some problems too when I won't be able to extract something in an interface, for example, static members or private methods. For this, for example, you can try to use abstract classes and extend them from a generator. And with this, I believe that IL weaving will become a niche tool because most modifications can be easily re-implemented with generators. There will be a slight implementation difference. IL weaving is difficult to debug and test, but at the same time, implementation details won't be visible during compilation. So for property changed, I would probably stick with Fody because I cannot imagine a situation where I'd like to debug this code. But for example, if I'm going to implement some equality members, I'm going to use source generators because I might be curious how, let's say, collections are compared. And some extensions are actually almost impossible to replace with generators. For example, with Fody, you can add null checks for every method. This is something you probably don't want to do with decorators. You are able to add configure await to every call in your program. And since this call might be located deep within a method, you won't have an extension point for source generators there. For example, with PostSharp, you can add deadlock detection by dropping a line in a log every time you work with some synchronization primitive. And unfortunately for these tasks, ILiving is still the tool to go. And ILiving is not actually the only way to generate some code. We also have runtime generation, which is usually done with a type named ILGenerator. If you haven't used it directly, you might have used expression compile that uses it under the hood. And it is often too used to add some functional aspects that require a lot of boilerplate. I've personally used the ILGenerator type to provide some login decorators and encryption over some messaging interfaces. And if everything you need to extend is available at compile time, you can simply replace the ILGenerator with source generators. It will work the same. If something you need depends on runtime arguments, for example, if you want to provide methods that will process some regular expression, and it might be provided by your customers from a user interface, and you don't know them until runtime, source generators are entirely a compile time tool. So in this case, you'll still have to go to the source as the ILGenerator type. And one other tool I want to mention is reflection. It might be a bit surprising because reflection doesn't generate any code, does it? But actually, we often use reflection to write less code. For example, for serialization. Whatever framework you are going to use, units of JSON, system text JSON, data contract serializer, XML serializer, in order to serialize an object, you need to know what fields and properties does it have. And this is often checked with reflection. But actually, we could have provided a serialization method for every type in our project and update it every time we add or remove some fields or properties in it. We usually don't do this because it's a lot of code and a lot of maintenance. But if we can generate these serialization methods automatically from a source generator, it won't be a problem and we won't have to use reflection. And there is actually a project that does exactly this. It's called JSON and it adds serialization methods to JSON to types in your project. And according to its maintainers' measurements, the first startup time and first serialization time is a few orders of magnitude faster than when using system text JSON. So if everything you need is available at compile time, another example is dependency injection container building, which is often done by registering every single type in an assembly that is found with reflection as the implemented interfaces that are again found with reflection. You can simply provide some customized code from a source generator to either serialize your objects or to build a dependency injection container. And if something depends on runtime arguments, for example, runtime object inspection, or if you want to work around some compiler limitations, such as access to private members, reflection is still the tool you'll use. So with ILGenerator and reflection, everything depends on the way you use them. Check whether it makes sense for your particular scenario to replace them with source-generated code. ILviewing, I believe, will become niche, but they still have the unique pros. And the only tool that is likely gone is text templates, because just as source generators, they only create new files. They have their own syntax without direct support in most IDEs. And for example, Roslyn, our compiler, is already using source generators to provide syntax types from the XML declarations, something where text template would be applicable. You can check pull requests that uses source generators there. And the only advantages text templates have, they can create any files. They are not limited to just C#. And you have much more fine-grained control on when text templates are executed, because source generators are going to be triggered by the compiler every time something has changed in the code editor, and this might be a bit too often for some CPU and expensive tasks. And in the next section, I'm going to explain how to deal with some common problems. For example, how to handle dependencies in your generators. What if you want to use multiple generators, how they will fit together, how to let your colleagues know about some generated members, and how to make a generator configurable, what to do if you need some additional data that is not a part of your C# project, how to let your customers know about some problem, and finally, how to make a generator faster. And probably the first problem you might have is you don't want to declare your own generator for some common tasks. So there are some good news. Generators can be added as a regular Nuget package, and sharing your own source generator is as easy as with any raw analyzer. But if you're going to write a generator you're going to share with the community, don't forget that you are writing code for someone else's project. For example, don't forget to check the target's project's language version, because there's a common misconception. People tend to think that source generators are C#9 feature. Actually, you can use them even with earlier language versions as long as you're using the modern compiler. So these people will probably not be happy if you add some pattern matching or covariant return types in their solutions. And actually, source generators aren't even a C# language feature. You can declare generators that will write some Visual Basic code as well. And don't forget that your code has some dependencies. For example, if you're going to provide serialization members, you might want to use some common libraries such as newtons of JSON for, let's say, arrays of primitives. And don't forget to take a public dependency on this package, so everyone who will reference your generator will also get this assembly and won't have to wonder what they need to reference in order for the generated code to compile. And another interesting question is what to do if you have multiple generators. Whether you can declare an order of the execution, what to do if you want to use something that will be added from another generator in a different one. And the short answer is that generators are completely independent. Everything the compiler passes to your generator is immutable, so you cannot affect any other generator in any way. And every file from all the generators will be added all together to the resulting compilation. So when any of the generators is executing, there is nothing that will be added by other generators yet. So if you need to add something that relies on another generator, you can simply use it within your source code. It won't be a problem because when this code will be compiled, everything from the other generators will be already added. And if you want to extend something from different generators, for example, to add login injection to some interface and then add caching to it, the one approach you can use is decorators. So simply provide one decorator from one interface, another from another generator, and you'll be able to combine them in the actual source code. And one final advice here before we'll go to the second demo is use the new partial keyword. It got extended in C#9. Before that, we could only use partial for private members that won't return anything. So if you don't provide an actual implementation, the invocation can be omitted. And now we can use them for public methods. Doesn't matter whether they return something or not. And because we'll have to return something, this invocation cannot be skipped. So what you'll get there is essentially an abstract method that requires an implementation within the very same type. So in this case, I'll have to provide the second part of this type and provide an actual implementation for this method. It might seem a bit strange. Why would I need to declare something only to immediately implement it? But as you've probably guessed by the topic of this talk, the second part might be source generated, in which case the original declaration serves two purposes. First of all, there is now a place where you can put an attribute to control what is generated. And second, a few years later, either you or your colleagues won't have to wonder what methods are available in this type. They immediately spot this declaration and will be able to use it to navigate to the actual source code. And let's get to the second demo for a few more examples of what you can do with source generators. Here I have login injection implemented with a source generator. There are some services that demonstrate how it might work in some bank application. I can calculate balance for my clients. I can check what accounts they have. And I have an extension method with login provided by a generator that simply wraps an interface in a decorator that will add some login for it, as I mentioned before, with decorators. So let's check how it works. I'll need to compile this project first. The generator is operating with a log attribute. So I simply annotate any interface I want to extend and process it from a generator. And here I request how many money there are on some accounts for one of the clients, John Doe. It also checks what accounts they have. There are 2 accounts, and in 568 milliseconds, I might want to check what's the performance problem here. I calculate that they owe me $5,000 US. And for the second client, Jane Doe, there is actually an exception that is thrown, and I now know where it happens, with which arguments I can debug this problem. So that's login injection, and here's the generator that does it. It's on purpose very similar to what I've built in the first demo. It simply checks every single file in the target project and check every type declaration in it. After that, it checks what types are annotated with my log attribute by checking, say, attribute classes. And if it's an interface, I'll simply provide a withLogin method and a decorator. So this code is not really interesting, but let's discuss how we can improve this generator. And checking every single file in the target project is not very good, because there are large projects. For example, ResHarper solution has about 650 projects. It compiles about 5 minutes on my machine. So if I'll add a generator that will work another 5 minutes, it will already be somewhat bad. If I'll add 10 generators, I'll have to wait about 1 hour for this to compile, and I'll never agree to wait such a time. So checking every single file is not what we want. And instead, you can subscribe to compiler notifications about syntax elements that are there in the target project with the initialize method. In its context, there is a single method, a register for syntax notifications, that you can use to provide a syntax receiver. Syntax receiver has a type that should implement an iSyntax receiver interface. And this interface contains a single method on visit syntax node. So when the compiler first checks what is there in my project to provide you with the compilation object, it also checks every syntax element in the target project, and it will fire notifications for every generator about the syntax elements it found. So I can check that syntax node is actually a type declaration syntax, and I can check that it has some attributes, so I might need to process it in my generator. Simply check that there are some attributes, and I can store them for later. For example, I can add this declaration to a hash set that will store type declaration syntax elements. And this run will be shared among all generators, so the compiler will only check every file in the target project once and notify every generator about it. So here, instead of checking every single file myself, I can instead access context, syntax receiver, cast it to my syntax receiver type I've just declared, and I'll be able to work with an already populated hash set of every type declaration in the target project that has some attributes instead of checking them and finding them by looking through every single file in the target project, and it will work exactly the same. And it might be tempting to check whether it's the log attribute they're annotated with, and it might seem that you have everything you need from the syntax element. So attribute list, we can select many attributes in it, and we can try to check whether any of them has a name that equals to our log attribute. And in some scenarios it might work, but I want to warn you against it, because in real projects log attribute might not always be written like this. It might be written in the full form log attribute, it might be written with some namespace, and it actually can be written with an alias, because C# supports them. So you cannot check that something is named log. You need semantic model for this, and it is not available there yet. So simply store every single type that has some attributes, and then check them in your actual execute method and move this semantic model get declared symbol method as early as possible, because working with syntax is not always convenient. And another problem with source generators is they are triggered very often by the compiler because it doesn't know whether some changes in the code editor require you to restart your generator and produce something different. So if I type console write line, this generator has just been triggered 60 times. So that's 3 times per every symbol I've typed in an editor, which is a lot. And instead, you might want to check whether someone is still interested in what you are going to generate with context cancellation token, because maybe your customer has already typed something else and there will be another run of this generator. And you can check this throw if cancellation requested. And this method is actually very interesting because it throws an exception. And it's probably not a problem if nobody is interested in what we are going to generate. But what if there is an actual exception in your source generator? So what if it runs in, let's say, null reference exception or in any other kind of exception? Will you as a customer be able to debug what's going wrong and guess what the problem is? Let's check it. And when I compile this project, I'm definitely going to get some errors about the login implementations not being there. And the only error I have telling me that the typo namespace name login impl default, which is supposed to be generated from my source generator, is not there. And as a customer, I might wonder whether I've annotated everything properly, whether I've configured the generator, whether it was run at all, or I forgot to add some output item type analyzer, for example, or if there is some other problem and my generators are simply not executed. And it's very inconvenient. So you actually have a warning telling you what's wrong there. It's telling you that generator login proxy generator failed to generate source. It will not contribute to the output and compilation errors may occur as a result, which we observe. And this warning is easily lost among compilation errors it triggers. So I have no idea why the compiler team has decided that emitting a warning is enough here. And I recommend you to lift it to an error with MS build warnings as errors. Note that regular warnings as errors won't work here. You'll need the MS build prefix. And now the next time you'll compile this project, you'll get a very clear error telling you exactly what is wrong with your generator. And you'll know that it was triggered and it's configured properly, but there is some error in it, and you might want to contain the generator author or debug this generator yourself. Now I have an error telling me exactly what is wrong. And speaking about misconfiguration of generators, here I simply ignore every log attribute that is not placed on an interface and not generate anything. This might be quite inconvenient for your customers if you are using this generator for the first time. So for example, they might accidentally place this log attribute on the actual implementation types instead. So let's check what we'll do. Our generator in this case. And I've moved to the log attributes. Let me recompile this project and check what errors I'll get and whether I'll be able to understand what's going wrong here. And yeah, the only error I'm getting is telling me that the typo namespace login input default is not found. Again, I have no idea why the generator has not generated anything. And this is a problem that you as a generator author can solve. You can add some diagnostics from your generators. So essentially, generators are code analyzers. You can provide a diagnostic ID and category, such as log generator. You can tell your customers what is wrong. For example, log must be applied to an interface. And you can tell the compiler whether it's a warning or an error. And last but not least, you can provide a location where the problem has happened. Every syntax element has a method called getLocation that you can use to guide your customers to the exact place where the problem has happened. And now, if I compile this project again, I'll see a few more errors telling me exactly what is wrong and how to fix this problem. I can simply double-click on this error telling me that log attribute is misused, and I'll see where the problem is. I'll see how to fix it. So let's fix it again and run our generator. And by the way, there is another interesting problem with the log attribute. It is not clear where your customers are going to get it. Right now, I have to provide my generator with an instruction telling my customers, please don't forget to use this log attribute, declare in your code and use it to configure my generator, which is quite inconvenient. And it might seem that we can simply move this attribute to our generator as well. After all, we're generating code for this project. So log src is this log attribute, and I can simply add this source file, add source log.cs, and everything should work. So let's try it. And unfortunately, the only error you'll get there, again, will tell you that the login impl default is not found. Let's check that it actually happens. And there are no other errors, so the log attribute is resolved correctly, and you might have no idea why it doesn't work. And as I mentioned before, every file from every generator, including your own, will only be added after all the generators has finished their work. So until there is no log attribute in the target project. So when you ask the target project to provide you with log attribute, it is not there yet. And it's quite inconvenient. So in the future, the compiler team wants to provide you with some API to add some static sources, for example, some attributes you might need in the initialize method. But for now, we have a method called compilation add syntax trees, where we can add some syntax trees to the target project. And for this, we'll first need to parse them, C# syntax tree, parse text, this log attribute. And I'll also need to provide C# parse options to tell the compiler what language version should use, for example. They will be the same for every file in the target project, and they are available from your context. So this will be our log syntax tree that I'll add to the compilation. And as I mentioned before, every method you're going to call on the compilation object is pure. So what you'll get is a new compilation object that will differ from the original one by this one attribute. And the scope of this compilation is limited to your generator, so you won't be able to affect any other generator or the resulting project. You'll simply be able to use the log attribute that you just added. Don't forget to add it to the actual source code of the target project as well. And now everything will finally work, and you'll be able to pack the attributes you need to configure your generator as a part of it. Let's check that everything works. I should get the login attributes working now. Oh, I've hidden the console window. And I'm still getting everything. And there is one other thing you might want to configure in this generator. And the problem is that this is some sensitive information. I print the names of my customers, their contact emails, how much money they owe me. So at least in production, you might want to hide this information behind some encryption. And this generator might not do this yet. And you also might not want to do this in debug because your developers might have a hard time deciphering every log when they try to develop your application. For this, you can provide the generator with an access to some MS-built properties with the compiler visible property. Include a property named log encryption, and you'll be able to set it, for example, a directory build props file for your solution. Let's do this. And I'll set it to true only in release mode. So encryption true. And now I can access this property from my generator and change something based on it. I can use context, analyzer config options, global options, access this property with a build property prefix. I'll get a log encryption string. I'll be able to parse it to a Boolean value. I'll get whether someone wants me to encrypt this log. and I won't write any real encryption in just 5 minutes. So let's simply use this variable encrypt and change something. So we'll see that something has changed in release mode. For example, I can use system convert to base 64 string coding UTF-8 get bytes for my original message. I'll pass this parameter from actual method. Now let's switch this to release mode, and you'll see that we now cannot read this log without some tool. Because base 64 encryption is not a real encryption algorithm. It simply transforms some strings, so don't use it in production for some sensitive data. So let's simply check that something has changed in release mode. And in real production, you might want to configure an actual encryption key for your generator. And this again might be a bit tricky because you don't want it to be as part of your generator. Yep, we cannot read this log anymore in production. And if you want to provide encryption key, you might not want to see it as a part of your generator because it might be a third-party generator. And you might even not want to see your encryption key in your repository because a lot of people might have access to it. And for this, you can provide an additional file for a generator that will only be available, let's say, on the build server. And you can provide some file, let's say, log encryption key that you'll be able to read from a generator and use as an encryption key. With context, additional files, you'll be able to find first file that has .key extension and use its text as an encryption key. And with this, you can gain access to something that is not part of the target compilation. So it is not there, but you'll be able to use this file as an encryption key. And last but not least, I must warn you about some security problems, because not every generator you are going to find might be good for you, and you are not from it doing something like this. Util send sources to my email, and I'll pack every single file in your project in an email to hack@gmail.com. Here I've commented the actual SMTP send call, and I'll leave a line knock knock now, all your sources are belong to us, to let you know that all your sources have been stolen by a generator. And you might wonder what's the big deal here. We have Roslyn analyzers for a few years by now. They can stall our source code. It hasn't been a problem yet. We can run some third-party code and it might execute something, for example, the console write line, as I did here, as a part of this third code library we referenced. So how generators are different from this. And one interesting distinction is that you don't need to actually call anything. So let me remove everything from my main method, and I'll still be able to print these two lines, knock knock now, and they will be executed as a part of your application with its rights. It might be a web server running with administrative privileges, or there might be some database connection strings nearby with databases, some sensitive information. Or it can be an application you deployed to your customers, and I might use it as a backdoor to them. Any other year, I would have hard time stressing enough how problematic this could be. If you followed news earlier this year, you might have heard about SolarWinds breach. And some hackers are getting access to a build process of the company and injecting some code in their product, so it can be turned into a backdoor for their customers. Among them, there are some very influential companies, for example, some of the United States government structures. And what source generators essentially are, they are a part of your build process that will inject some code into your program. So it's essentially a ready backdoor if you haven't checked what is the source code of your source generator. Here I've used a model initializer to simply run some code even before your application is fully loaded. It's a new C# 9 feature. And unfortunately, one other difference with a third-party library is that third-party libraries code is static until you update them. And with a source generator, you might check that the generated files don't contain anything problematic, but you cannot guarantee that the second run of this generator on a build server will be the same. So it might try to check whether you're running in release mode, whether it's running on a build server, and change some code injected in your product. And to be safe from it, you can ask the compiler to emit every file generated by a source generator on the hard drive, for example, in the generated folder with emit compiler generated files true. And this is an option I recommend you to set on your build server so you can check what is generated during an actual product build that you are going to ship to your customers. So let's check that this folder is there. Of course, you also need to check that these files aren't tampered with, because the generator might spawn a process that will try to clean up it. And you'll see a folder with this generator and some suspicious file called hex.cs, so don't overlook it in production. And I hope that this won't scare you off source generators, because this is essentially the risk we have with every third-party code. So if you're going to use them, leave CS8785 warning to an error with MS-build warnings as errors. If you're going to write source generators, don't forget to check context cancellation token and use asyntax receiver to make your generator faster. Produce diagnostics to tell your customers what's wrong with your generator, and pack every attribute you need as a part of your generator. And to wrap it up, source generators let you create boilerplate code easily, which makes possible to do some performance optimizations at startup, for example, by eliminating reflection. And they solved a lot of typical metaprogramming problems, such as navigation to the generated code and debugging, test coverage for code generation process. And finally, they're easy to use, because write something as a string is something we do every day in the code editor. It's not as difficult as writing some bytecode. And because of this, many metaprogramming tools become niche, but since generators can only add new files, they're still with us. And if you want to use some examples of source generators available today, there is a very useful list of GitHub projects containing them. There is an SVG2 C# source generator you might want to check that transforms SVG files into types returning a sky picture. There is a JSON assertgen I mentioned before that provides serialization to JSON without reflection. There is a generator provided by Microsoft, Win32p involve generator, that adds Win32 methods and all required types to your project. So check it out. And if you now want to write your own source generator, check Source Generators Cookbook from Microsoft. There are a few examples that I explained in details. If you're interested in something I've built during this session, for example, how to test your generator, you can check these examples on my GitHub account. You can try to go to SourceGenDev and use some examples there to play with them. And I'm looking forward to what you're going to build with source generators, but don't forget that with great power comes great responsibility. Every link you'll be able to find on a GitHub used by this QR code, and thank you for watching.
Right. Let's add ourselves back. Yeah, there we are. Thank you, Andrey, for a fantastic talk. It's a really deep topic, and I think you managed to squeeze 5 hours of amazing content on source generators into 1 hour. So thank you for that. Absolutely.
Definitely.
We do have some questions that came in, so let's see if we can get them answered.
Sure.
First question that came in was really about the tooling that you've been using. So I think you mentioned sourcegen.dev at the end in the resources.
Yes.
Are there any other tools that you recommend to see and inspect syntax trees and get familiar with what you can do with them?
Well, Sharplab.io is a website I've used to check what Roslyn generates for some arbitrary code, and that's where you can check how some syntax elements are named, which could be very useful if something will change in the, for example, C# 10 version. So if some code is processed differently, you'll be able to check how the new element is called, and will be able to update your generator according to it. And that's what I usually use when I want to work with the compiler. So nothing really fancy there.
All right, that makes sense. Then a couple of more practical questions, I guess, that came in from a couple of people. Are there scenarios where you do not recommend using source generators?
First, I would definitely recommend you to check the source generator's code if you're going to add something to your project because of some security risks. And if you cannot afford to do the code audit or at least check what is generated, that's probably not something you want to add to your project. And personally, I don't like source generators for the property change notifications because I'll see my backend fields and I'll never want to debug it. It might be a bit cumbersome to use if I want to extend every single method in my project, for example, with null checks, because I cannot move, for example, private methods to interfaces to provide decorators. So for some tasks, I would definitely still prefer to use IL weaving.
Yeah, cool, that makes sense. Yeah, you mentioned seeing the code and so on. So I guess that ties in nicely into the next question that we got. How easy is it to unit test generators? Do you generate plumbing for those, or are there libraries that people can use? Or
I haven't seen any libraries, but since I've written a couple of generators myself, I simply added a single line of code that compiles some arbitrary source and runs generators over it. So it's a single method. I don't think you really need a library for that. And you can check it on my GitHub and add it to your unit test projects. And after that, it's a simple compile some source code and run generators over it, check what it returned. So
I can add there. What I really like is Verify by Simon Kropp. That is really cool because you can grab the generated code and then compare it with a verified snapshot of what has been generated before. That's really cool.
Cool. All right, we have a couple more. Matthias, I think you were creating a list of questions as well.
I also have one. That's more bit more far from the topic. I mean, slightly a bit philosophical. Are you still looking forward to have like proper AOP support in C#? I mean, source generators have a bit of limitation, making the original class partial and stuff like that. But do you think with options that we have like PostSharp and Fody, you mentioned both, something like proper integration for AOP is still interesting?
I believe it definitely is still interesting because source generators have their limitations. I mentioned a couple before. For example, it will be really hard to change something within the method, in the middle of a method, or change something that requires you to provide an extension point for a private method. And because of this, I would definitely still use AOP, but I don't believe that something like this is going to be provided as a part of C# compiler now, because they have their own tool and every other scenario is already covered by existing IL weaving tools such as Fody and PostSharp.
Yeah.
So it still has its use, but I don't think it will be integrated into the C# language right now.
Yeah, I guess it is pretty niche. I mean, there are usually you just have a handful of how to say, very specific use cases for AOP. At least that's what I remember when I studied a bit about them. One thing that I remember. Do we still have a bit of time?
Yeah. Go ahead.
One thing I remember, and I'm sorry, maybe you mentioned it, but I had to run for the door really quick in the meantime. One thing that I discovered is usually you're limited by this partial declaration of methods and types, right? What I found also works pretty nice, and it was more by accident, is that you can derive from the original type and just make it hide the other one. So do you know what I mean?
Yeah,
Like
I understand what you mean. It seems a bit hacky to me because imagine that a few years later your colleagues will find this and they'll try to navigate to some method and they'll have no idea how to look for something you've generated. So I would not do this. But I've been toying with an idea of working around source generators limitations. For example, if you actually want to provide some extension points within a method, let's say to add login every time you work with some synchronization primitives, another interesting approach you can use, you can simply generate a copy of the original type and simply put all the required strings there and use this copy instead of the original type. So The generator will basically see everything that is declared in your project. You can simply provide a copy and augment it the way you want. As long as you are using the generated type, it will not have any problems with extension points.
All right.
All right. Yeah, I have a couple more questions that are that seem to be coming in. So that's always nice. If you have questions, do feel free to ask them in the chat, and we'll see if we can ask them to Andrey. One of the questions we got was on compilation time. You mentioned that source generators essentially run individually and run as part of the compilation, of course. Do you notice any noticeable slowdown in compile times or something?
Well, as I mentioned before, I've actually measured. They run on average 3 times per every symbol you type in the code editor. So if you don't see any critical lags in code editors, then probably source generators are working quite fast.
Yeah.
And you can alleviate this problem by bailing out early with context cancellation token. You can also use a syntax receiver I mentioned before to make the exploration type linear across all generators. And quite frankly, there is now a lot of things going on in your code editor. Every time you change something, there is a Roslyn analyzer that has to provide you with code completion, that has to know everything you've changed, which members are available to highlight something. There is a ReSharper analyzing that does similar things. So if your generator doesn't do any, let's say, web requests and updating gigabytes of data, it's not usually a problem. If it is, one approach you can use is to wait some time before doing some heavy loading, check whether the cancellation is triggered, or you can switch to text templates, because with them you'll have a much more clear and fine-grained control over when you do some heavy loading.
Andrey, thank you again.
Thank you.
And we'll see you around.